first came, we ramped up in faculty with 5 or 6 new faculty. Julie Heigl came, Ron Askin came, Paul Sanchez came, Marcel Nutz came, and really got to be an operations research powerhouse. Right now we're the largest engineering management program in the country in terms of graduates per year.
You know, being a student here, I had a lot of memorable faculty members. Don Schultz was my PhD advisor. He sort of set my tone for life. He had an open door policy for students to come in. Wayne Wymore was one of my favorite instructors, and he taught this theory of systems engineering, which is mathematically very elegant.
I think Wayne Wymore was the first department head. He actually came out of the computing center at the university. Wayne started a systems engineering program, it was the first in the country. I think it was in 1962, and the things that he talked about have led to the national organization in COSI. I mean, he was a founding member in that group.
He would get up to the chalkboard. In those days we had chalkboards, no whiteboards, chalkboard, and he would have all his lecture written out in these notebooks. You know, he'd have it all written out and prepared, and then he'd go a mile a minute. You know, just put this stuff up on the board. You know, and interrupting him with a question was almost impossible.
Wayne Wymore, yes, I did know of him, and in fact I probably took classes from Wayne Wymore when I was an undergraduate a few decades ago. When I graduated with a slide rule. Now most people don't even know what that is. As soon as I got out of school, the first calculators came out. Well, look at it today. Everybody's got a laptop computer, calculators with more power than most computers of the past. So technology is really driving this industry and this department.
I actually think my favorite class was SIE 250, which is the introductory course to systems and industrial engineering. The department head, Dr. Head, teaches that class.
My favorite class here is actually SIE 649, stochastic programming, but it's called Topics of Optimization.
I would have to say SIE 321, which is probabilistic models and operations research with Dr. Guzin.
I mean, I look at the research portfolio of the entire college, and we're starting to think about what I call big ideas now. We're going to start to work a lot more on infrastructure and measuring how good our infrastructure is. So our transportation work is going to be important as well. The ability to take data and make inferences, I mean, it's a fundamental SIE skill, is going to be important in every project that we do, whether it's in biomedical engineering, electro and computer engineering, mining, in geological engineering. This whole notion is we collect more and more data and then do real-time analysis and make decisions on the fly. Perfect idea for SIE.
One of the areas that related to my research is the big data, which means, you know, we have a lot of data. Sometimes it is a kind of disasters. So for example, the social network, Facebook, there will be tons of data generated every second. But how to proceed to analyze those data to get useful results, I think that is something SIE people can do well.
And this is our new reliability engineering lab. Actually, University of Arizona used to have a very strong reliability program, and I'm here to bring the reliability engineering back to UFA.
This is the computer simulation of the emergency evacuation the scenario. So the law enforcement people can use this tool to the training their personnel as well as to evaluate the lots of the different the evacuation management policies.
University of Arizona has a long history of, through the Lunar and Planetary Lab, of building instruments, right? But they brought it to the next level in 2003 when we were able to win, to lead a full-scale mission, which was the Phoenix mission, and the building that you see here was originally the Phoenix Mission Science Operations Center. And what we're doing the system engineering of the whole Science and Processing Operations Center. Basically, with my students, we are architecting how the whole data system is going to operate with the telemetry streaming down from the spacecraft. Building from that, you know, we expanded, and now we are in charge of a $1 billion mission overall. This is probably the most complex robotics mission that has ever been done. So it's really hard at this point to imagine something bigger. But I think what is really important is that here we are creating infrastructure for getting more and more business.
We have a young, new faculty going in new directions. Everybody is strong and excellent. Everybody has an active research program. Everybody is connected with students. We're doing things in space systems engineering, Roberto Fafaro and the OSIRIS-REx program. We're doing things in healthcare. We're doing things in lots of areas that affect everybody. And if our alumni can look out there and see the diversity of opportunities that they've had and look at where we're at with this young faculty and our growing student body, this really shows the opportunity for growth and making this department great and helping us be a real contributor to the College of Engineering, the University of Arizona, and our profession.